So, hi everyone. Welcome to this session about robotics. We're going to talk about where do robots add value. I'm just going to briefly introduce myself about what I experienced on robotics. When I was a little kid, I was being asked, draw a washing machine of the future. And this was what I came up with. So that was my robot. And it looked a bit like, for the Dutch people among us, that was a Dutch television program. And on the right side, there's my daughter. And this is how she experienced robots at the moment. So a lot of things changed. And that's also really nice to discuss with this panel. We have a great panel of research and two companies that have robots as a business model themselves. A little short introduction on the field of agtech and innovation. So a lot of things are happening in that space. So if you look at the investments flowing to agtech from 2012 up to now, then you see almost a 15-fold of the amount of money flowing to young, innovative companies focusing on solving problems in the food and agtech space. And if you break that down into categories, then maybe a nice question, or you can ask that yourself, where is robotics in this area? And maybe it's also a good question to ask, what is the 18 billion? It was after the pandemic in 2021, so there's e-grocery, so all the delivery services that had huge valuations. But in the space of robotics, it was almost 1 billion. So my conclusion is a lot of room to grow. And hopefully that is also the discussion points with our panel. So good to move over to the first speaker. And that's Jochen from Wageningen University. So we have 3 presentations of around 10 minutes. And afterwards we have room for questions. And hopefully we get a bit of interaction with you, the audience. So think after every presentation what kind of question you would like to ask. And afterwards we have around 10 to 15 minutes to address all those questions. So Jochen, hands to you.
Yes, now I can hear myself. Yeah, good afternoon, everybody. My name is Jochen Hemming. I work at Wageningen University and Research here in the Netherlands in the business unit Greenhouse, Horticulture and Flower Bulbs. In the next 10 minutes, I would like to tell you a little bit about research going on at our place. Wageningen University and Research is an organization dedicated to life science. And we have 2 parts. Wageningen University with the primary task of education and more doing the fundamental research. And we have Wageningen Research, which is an assembly of a number of research institutes that do contract research. And I'm from Wageningen Research. I'm a senior researcher, computer vision and robotics in horticulture. And we have something special in Wageningen that we call agro-food robotics. That is a program where different researchers from the different science groups, plant science, animal science, environmental science, food science, work together, share the people, share the knowledge and the technology. And we mainly do projects on computer vision. We do a lot on spectral and hyperspectral imaging. Artificial intelligence is a very important topic, and deep learning when it comes to image analysis. And that all comes together in these robotic systems, which is also my research topic. If we look to the current state of the art in greenhouse robotics, there are quite some commercial examples out there. You have advanced logistics, autonomous transport in the greenhouse, like on the lower left picture. You have all kind of automation. You have machine vision-based sorting and grading systems. You have also robotic arms doing something, like these robotic cutting planters you see in the middle on the ISO group, for example. And you see a lot of packaging and pelletizing robots. But if you look closely, this is all not in the greenhouse. This is next to the greenhouse. This is where the sorting and the packaging takes place. So what's about in the greenhouse? There we can still notice a massive amount of human labor. And we all know the problem. There's reduced availability of skilled labor, of labor that is willing to work in that environment, which results in an increase in labor cost. We have also seen, and we have done ourselves at Weir, a lot of research going on in robotics, but if we look closely, there are only a very, very few commercial systems out there. You see a lot of robotics also here in the exhibition hall, but if you ask closely, most of them are only in a pilot case. It's not really a commercial product. So what makes it so challenging? So why are not all these robots out there? And there are a number of important challenges. And the first one is that we have to deal with the natural environment and the large, high variability of the objects we deal with, but also of the environment, and that also changes over time. If you look to the top right image, these are all tomatoes. But yeah, they range from small to big, from green to orange to red. So it's a lot of variation, and if you build a system that has to deal with that, that is quite challenging. The next challenge is that we often have to deal with incomplete information and with what we call occlusion. If you look to the lower right picture, these are apples in a tree. Apples are in front of each other, they are overlapping. There's even a leaf covering a large part of one of these apples. There's sunlight, there is shadow, so there's a lot of variation, and you see not the full scene you would like to see. And the third big challenge is the environment we are in. You have changes in light conditions, sunlight, cloudy weather, outdoors, maybe even rain. You have large temperature differences. In the greenhouse can be very hot, can be very humid, and that is all not very suited for the technology we are using when it comes to sensing systems or robotic arms or grippers. And in these 10 minutes, there's only time to show one example on research which is currently going on at our institute, that is on robotic harvesting of gerbera flowers in the greenhouse. We have a demonstrator on our booth here, actually, you can visit later on. We see a picture of gerbera flowers from the top, and the first task is to detect where are my ripe flowers and on what location in the 3D space are they. So I need to localize them, and we use deep learning for that. Actually, all recent agriculture robotics projects use deep learning when it comes to image analysis, because that really has boosted the performance of the vision systems a lot. So the detection gives us ripe flowers here in a greenish color. There are other flowers, flower buds. These are more in blue. That is the ones which are not yet ripe, which we are not going to harvest. A next important thing is that when it comes to the robotic hands, what we in robotic terms call the end effector, that turns out to be very specific to a specific task. So I need a different type of end effector when I harvest a tomato than when I need to harvest a cucumber or to harvest such a flower. And it's a very dynamic environment, so the control of the robotic arm must be able to deal with that. And so we detect the ripe flowers, and then we need to decide from what direction can we approach the flowers. Where is free space to operate the robotic arm? That is indicated by this orange color. So where, and the arrow then shows us what is the best approach direction to go there with the robotic arm. And just to give you a little bit of glimpse, I would like to show you a few seconds of a video clip. So this is the research prototype we have developed over the last 2 years. There's cameras on top doing the analysis where the ripe flowers are. Then there's a gripper that stabilizes and grips the top of the flower. And there's a second part of the end effector that is very flexible, that descends along the flower stem. And once, when it has reached the bottom, there's a scissor, a cutting device that cuts off the gerbera flower. When humans harvest gerbera, they typically make a sort of braking movement to a certain direction. You can do that with a robotic arm as well, but that takes much more time. And in the case of that project, we decided to go for a cutting mechanism. There's more going on in Wageningen. There's no time to show it all here, but we work on harvesting apples with robots. We also work on robotic pruning of bushes and trees. We look into how can we harvest a pear, and what is common with all these projects is that we need a lot of 3D information, and we need a good hand-eye calibration and a good hand-eye coordination of all these systems. And that brings me to my last slide already. So what are trends in research and what is the outlook? We can state clearly and can see clearly that if we work with robotics in the agriculture environment, and we want to manipulate the plant, we want to do something with the plant, we need 3D information. So 2 dimension is not sufficient. When it comes to the development, it has a lot of advantages to have a digital twin or a physical twin, a good simulation environment where we can test all year round, where we can maybe test behind the desktop or we can test in the laboratory. In the case of the apple harvesting, for example, we have only 6 weeks roughly per year where we can test the robot in the real world. So having a physical twin or a digital twin helps in development and testing. When it comes to the robotic hands, I think what I have seen over the last 20, 25 years, it's all very tailor-made and for a specific task. You don't have the universal robotic hand that's like a human hand, but you have a specific end effector, a specific gripper or cutting mechanism for your specific task, and that is specifically developed to do that. Soft grippers is also a very interesting topic, but there are also downsides on soft robotics when it comes to, for example, durability or hygienic issues and so on, but of course also an important topic. What I also see in the last years is that we go beyond only visual sensing. I mean, all these robots you see have cameras, which is the most logical to do, so you look where you have to go when you go there, but the new development is sometimes you cannot see where you have to go, and then you would like to use other sensor modalities like tactile sensing, like force or torque feedback, and then you have to fuse all these sources of information to get the right control for the robot out of it. Artificial intelligence for data analysis and for reasoning, so for my low-level and my high-level control is very important. I already said deep learning for image analysis, that is what we have to do. There's still a very quick development and increase in performance in deep learning, and we follow that very closely. And then in the end, bottleneck is often that we are still too slow or too big, and then we cannot reach where we want to go. So the trend for smaller and better and more robust hardware and software, and also easier to use for the end customer, that's an important trend. And last but not least, the social component and the ethical questions. How are robots accepted by society or by the users? And this is also very important and addressed in research nowadays. To round it up, so variation and occlusion, what we have in the natural environment, are challenges and still hampering performance. And that's why these systems are not yet largely deployed in the commercial practice. If we know something about the domain where we are busy in, so we have domain knowledge and we have some experiment, that is, I think, key in success, and that is also what helps Wageningen to work and develop these kind of systems. I'm very convinced that the introduction of commercial robots will speed up in the coming years, and as you can see here on the exhibition also, most large machine builders are already part of a robot initiative. So it's really coming. And with that, I would like to conclude my short talk. Thank you very much.
Thank you, Jochen. And before we go to the next speaker, and hopefully he recognizes himself in all the challenges that Jochen is mentioning, please go and visit the booth of Wageningen University. It's really cool to see the robot in place. And so please afterwards visit Jochen at stage. And now we go to Arnoud, and hopefully he can elaborate a bit more on his challenges around robotics and the trends we're seeing.
So what button should I push?
The green one.
The green one. Okay, hello everybody, thanks being here. I work for Bosman van Zaal, and Bosman van Zaal is a project development company developing projects in agriculture and horticultural, like greenhouse projects with rolling table systems, but also vertical farming systems. We also do lots in robotics. Our mission is that we create movement, provide insight and facilitate growth Well, in the insight and the movement, we allocated 2 types of robotics. One of the robotics are the more repetitive robotics, meaning the robot arms that place, let's say, pots from one place to the other. And in Insight, we allocated the more advanced robotics that interact with the environment with the help of, for example, visual recognition. Oh, that was my introduction. So that's me. Oh, that's me. It says that's me. I used to be a rose breeder, so I have a little bit of knowledge of data gathering, introducing new species or products or whatever. And I became a software specialist. And because there's a lot of software involved in the advanced robotics, it became a part of my duty to work with those robotics. Okay, the movement part of our mission statement, we do a lot of the movement with the rolling tables, but also with these kind of robot arms. The SCADA robotics and the 6-axis robotics, for example, we use a lot in our products in order to increase or decrease labor cost. That is always the main motivation of implementing robotics in your production processes. It also increases speed if it's the right robotic. It increases accuracy and it decreases unsatisfying work. So work which is not creative enough, the standard repetitive work. But the disadvantage for such robots is that it's very inflexible. It only does one job. You can reprogram robotics like that, but in fact it's meant to do only just one thing. And of course there are the safety issues. You often need a big fence surrounding the robotics because it can be very dangerous to be in the neighborhood of such a robotic. What we see as a trend in these kind of robotics is the trend to cobotics, and that is that robot and man interact together in order to execute duties. The disadvantage of that is it's often slower. So I give you some of the examples. This is exactly the same kind of infrastructure Jochen, you were mentioning. This is what we do with the help of automation and robotisation. Well, this is not a robot. Okay, to save some time. At the more advanced types of robots, we're involved in 2 projects. That's the Inaho project. That is a cherry tomato harvesting or picking robotic. The challenges are indeed, it's a integration of 3 main elements as far as I'm for, in fact. That is the vision recognition software that needs to detect the right fruits to be harvested. The mechanics, because most of those mechanics like the battery or the wheels or let's say the physical composition of the robotic, that is, let's say, you buy from the marketplace most of the time. And the performance management and the predictive maintenance data that such a robot generates, because often you have 10 of those robotics operating in your farm and they all individually produce a lot of data. This is also data which is very useful because then you can see indeed how long a battery still is operational, how many fruits it picked, how many errors it gave or notifications in order to increase the performance of the robotic. Again, with in combination with the harvesting hand of the scissors, which is called the end effector. Why indeed here the most important argument is indeed to reduce labor cost and to reduce the unsatisfying work. But indeed the changing conditions to train the vision software, that's a very, very big challenge. The machine learning is a challenge. That's a very intensive work to make the robotic to recognize the right fruits to harvest. And the psychological hurdle, yeah, you already mentioned it, that's a big thing. This is an example of a robotic which has the objective to reach out to autonomy of, let's say, greenhouse activities. The next example is VDL, the robotic, the leaf cutting robotic, what you see here around the corner. We're involved in this project also, the crop tech. Well, what you see, the same, the 3D vision recognition software that detects the attachment of the leaves to the plant. In cucumber companies, 25% of the labor cost is dedicated to the deleafing of the plants. That's 25% of all labor costs. That important it is to automate or to robotize this activity, because the flow of people is incredibly high, meaning that you have to retrain over and over again the personnel, and you don't know what you're getting as a new employee. Again, what you see here, we can explode all the spare parts of the robotic for maintenance, predictive maintenance objectives, and we can register all the activities that a robotic does. So it's not only the robotic with the objective to harvest or to cut leaves, but also to make it more efficient all the time. And not only the vision recognition software, but the robotic as a whole. This might be interesting. Here we try to give a value to a robotic compared to the labor it should replace. So what we did, we isolated a couple of variables as the salary cost of one operator, of one worker per hour. Also the amount of weeks this job is executed, the deleafing of the plants. So we have all those variables we put into, let's say, a formula in order to give a value to the robotic. We can do this with a tomato harvesting robotic also. So we made a formula in order to estimate the value of robotic in the agri business. So the other element of our mission is growth, but it has nothing to do with robotics, so we'll leave that. And that was my presentation, so thank you very much.
Thank you. Maybe a quick question from my part. So do you sell the robot or do you deliver it as a...
No, what Jochen indeed confirmed, it's in the validation stage. So we're now gathering 5 cucumber growers for the VDL leaf cutting robotic to join us for a pilot group in order to test the robotic in a more quantitative environment.
So, and maybe a follow-up question. In the end, when it's market ready, will you choose for a business model around selling the robot or delivering it as a service?
It's mixed.
Okay.
It's mixed. So you buy a piece of the hardware and you buy a piece of the service.
Okay, thank you. That's interesting because we go to the next speaker, and that's Christopher from Denmark, and he's actually our neighbor. So if you can visit this booth after the session, you can visit him there, and he will talk us through his company and his story, and he has a business model around also as a service. So that's also nice to see that as a different way of delivering the robot to the market. So Christopher, 10 minutes ago.
Sure. Hello everyone, my name is Christopher. I'm the CEO of Seasony and one of the 3 co-founders, and as mentioned, we are right over here if there are some questions that arise a little later on. But basically, what it is we do is we started a little while back in 2018 with our own little vertical farm, had this vision of mobile robots in the vertical farming space, but eventually got a little smarter. So we figured out that mobile robotics alone for the vertical farms was a little better than doing everything ourselves. But what I want to talk to you about a little bit is a quick overview of the history of automation, because we've constantly, through the invention of the first conveyor belts that we've seen indoor, up until today, we've been going a little bit back and forth from rigid automation, CapEx heavy automation that provides a lot of the value that basically enables us to concentrate on fewer single elements of labor instead of having to do a lot of things in the facilities. And then to the more flexible solutions that we see with a human in the center. So here throughout history, we've seen that the invention of the forklifts themselves provided a whole lot of value for the individual warehousing operations. And then in the 60s, we eventually got to the ASRS type systems, which is basically systems built up around your racking modules to be able to transport goods back and forth and enable the workers to work at an individual stand. And these developments here haven't really changed a whole lot over the years. They have, of course, now the pictures are in color, but the essential components are the same. They've gotten faster and smarter, but the general concepts are very much the same. But during the last 30 years or so, we've seen mobile robots enter the scene much more. We started out with the AGVs, which is, of course, the autonomous guided vehicles, typically following some type of infrastructure. Could be magnetic strips in the floor, lasers, whatever have you. They'll typically operate a little more like a train following these lines, but now we've seen the advent of autonomous mobile robots, or AMRs, which is essentially a little bit smarter version than that. It operates much more like a self-driving car, making its own decisions as it drives around the facility, being able to drive around obstacles, drive around people, and work alongside people in these productions here, or in these warehouses. And we've seen very much the adaptation of autonomous mobile robots happen very rapidly during the last 10 years in the warehousing space. And that was really kick-started quite a lot with the acquisition of Kiva Robotics by Amazon. Now it's Amazon Robotics. And over the last couple of years, we see more and more of these AMMRs, which is these autonomous mobile manipulator robots, as you see here. And we've also seen a couple of examples through the presentations here today. And in the greenhouse space, we've very much taken that to heart. I think Jochen and the guys here have been talking quite a lot about the advent of mobile robots and the use of mobile robots in greenhousing. And there's definitely a lot of potential here. And the really reason, the background for basically adapting these mobile robots are that a little bit in the graphs here. One is, of course, the increasing labor costs that we've seen over the last decades that have continuously going up as we've actually at the same time seen robot prices go down. And those robot prices correlate very much with the use of sensors that we use on board the robots. We've seen, of course, 2D LiDAR actually do quite a lot for the navigation of the robots themselves. Of course, 3D visual autonomy is something that is becoming more and more prevalent within mobile robotics. And of course, Jochen already told you a little bit about the application of deep learning with 3D visual autonomy as well. So when we take a look at vertical farming today and controlled environment agriculture, we really see this level of automation typically today. We are somewhere between conveyor automation. We see that quite a lot in the vertical farming space. And we are now starting to see a little bit more of the adaptive automation that we have somewhere around here in the room today. So in vertical farming, this is the typical image you see out there. There's either a guy in a scissor lift doing all the work of moving plants in and out of the facilities, doing a lot of the documentation, doing all of the work from a scissor lift, basically. So here you have all the flexibility that you gain from having a human in the mix. You can have designed your system just for the plant growth itself, not having to worry too much about automation. And here you get all the flexibility that you need when shuffling things around on the day-to-day operation. But of course, the other types of systems are typically more capex heavy, but allows you to have a much more fluid production. It allows you to have a much more efficient production without all the humans in the productions here. So kind of bridging the gap a little bit is what we're trying to do at Seasony. We have developed an autonomous mobile robot to handle all the intralogistics in a vertical farm and essentially act as a platform for all types of technologies, everything from multispectral cameras to add to the robot, to robotic arms for harvesting strawberries, and of course gathering data throughout the entire facility of the farms. So this is a little bit what it looks like. I'm not going to bore you too much with how this works, but essentially the robots are navigating around the facilities themselves through the use of the Seasony OS, where you can actually schedule the robots' working days just like you would with a normal worker. So you gain a lot of that flexibility from having human workers, but essentially getting all the advantages of actually not having human workers. So yeah, I already mentioned this a little bit. Essentially, it's quite an easy thing to talk to customers and vertical farms about, because we can essentially start providing that labor cost reduction right away. As it's a robotics as a service model, this is something that really provides a lot of value. The increased yields, of course, comes from all the data that we can collect. I mean, this is something that everybody can agree is quite valuable, and data is very much the topic of this GreenTech this year. And of course, the partnership extensions is already something I talked about. So how do we get to the very bottom here? Of course, this is a very complex place to be, and there's quite a little way to get there. But I think some of the trends that will take us there is, of course, increased data collection doesn't only mean the data that we gather around the plants. It can also just be around the facility, how to operate better, how to optimize the use of the robots themselves. We'll see much more, cobots in the mix. We'll have a combination of humans and robotics because this is something that provides that flexibility in the individual productions. And the combined solutions of actually having robotic arms, having UVC lights, having specialized cameras is something that we've seen all over today, where we essentially provide just a platform for all of those technologies. And the last part is essentially cameras on robots are able to provide a whole lot of insights, not just to the growing operation, but also to the day-to-day flow. It can provide for health and safety. It can provide to optimize production flows. It can do quite a lot with the resource that we have today. A lot of it is already open source packages like YOLO. You can get quite a lot of insights into how humans are actually operating in the facilities and how to optimize on their production. Yeah, so that was actually what I wanted to go through today.
Give him a round of applause. Maybe first question for you, Christopher. As a young company, active in the startup scene, so how do you conquer the storm that is going on in the startup innovation ecosystem after the Silicon Valley collapse?
Yeah, that's of course that's a strong word. Silicon Valley collapse. The rising interest rate environment is, of course, something that's challenging for especially our customers in the vertical farming space, where costs have been challenging a bit. I think one of the biggest problems is just the volatility. As we see interest rates rise, and now we're leveling out quite a bit, we are actually seeing a much more calmness in the environment as a whole, raising funds for both our customers in the vertical farming space and indoor farming space, as well as the technology players, are getting a little bit easier than it has been at least the last half year to a year. So I'm quite positive because the overall trends are pointing in the right direction. Everybody wants to see controlled environment agriculture be much more prevalent, and everybody wants to see the effects of vertical farming put into place.
Yeah, good stuff. And if you can survive this storm, you're set for the future, I guess. So
hopefully,
good stuff. So we've seen 3, in my opinion, really interesting presentations. Are there any questions for the speakers? So yeah, gentleman over there.
Hello. Yes. I have a question. Let's say tomato tomato crop. Yeah. And if you design the harvesting robot for the tomato crop, let's imagine a row of the tomato crop is 100 meters long. Yes. And from this row there is about 300 or 400 kilos of tomatoes. Can you solve this problem, logistic problem?
Arnoud.
Well, first of all, as Jochen also indicated, there are so many variables we have to take into account in order to be able to give such an answer on such a question, because our expertise at this moment is the cherry tomato, individually harvested tomato. And it's under the conditions, it's tested in Japan as well as in the Netherlands. So these are also the volume of the greenhouse, the amount of light in the greenhouse, and the differences in day and night and the seasons, longer and shorter. So as a question like this, it's impossible to answer. But the objective, of course, is to manage these kind of operations. On tubes, 100 meters, harvesting as quickly and as accurate as possible your harvest, and hopefully there's only 10% left for human harvesting. Yes, it's the objective for all tomatoes under all conditions, if it has a minimum of technology, the operation, to help harvesting. And indeed, the first robot I showed you from Inaho, the Japanese harvesting robot, that's more a cobot because it's meant to interact with people. And the VDL leaf cutting robotic is more the aim to reach out to autonomy, and that's then without as least as possible human interference.
No,
So yes, in time we will do it, but in how much time? That's the question.
Thank you.
Maybe I can add to that, because I think, also in normal manual production nowadays, you have these kind of systems where you have very long crop rows, and of course also then the product gets transported out, and people are not carrying buckets out, so there's already quite some mechanics and for a part even autonomous transport available. So that is a part that needs attention, of course, and it's very important that when you talk about developing robots, it's not only developing a robotic arm that can pick a tomato, it is about the complete system. So how does the arm or the picking device fits into the remaining logistics, and I have to automate, if I want to have full automation, also that. So that's very important. It's also, we often get the question, how much does one robot cost? That is not the good question. The question is, how much will it cost to make a full automation of my greenhouse? And maybe I have to change the greenhouse as well.
Yeah, maybe to ask also Christopher, because that aligns with your story. It's more on a crossover from other industries. So how can we learn from other sectors that are using like warehouse logistics or robotics already?
Yeah, I mean, it's actually a really good point in terms of, we have to look at it as a system sometimes. Individual robots can provide some of the value, but if you really want to capture a lot of it, you need to look at it as a full system. When you look to the warehousing industry, you typically do a lot of simulations in the beginning when you first talk to customers. You see how many robots are needed to actually perform the task and how the business case is going to look in the end. So this is something that is a logical step to take in the beginning. But as you also mentioned here, Jochen, there's a bunch of solutions in the greenhouse space. If volume is the problem, this is something that is already a problem today. And then there's trolleys and there's different solutions for transporting things back and forth.
Thanks.
Yeah, but can I say something?
Yeah, yes. Sure.
But on the other hand, we discussed the reluctancy of growers to accept robotization. So, we can all go into the system thinking area, which I approve, of course. But first we need to convince growers to start working with one of the available solutions. And that's, of course, the most time-consuming, labor-intensive solution in order to get convinced and then invest more and more in robotization. So it's, for me, for a grower, as we experience them, it's difficult to have a holistic approach on robotization and automatization, although in some production areas it already happens with the roller table movements, what you've shown and what we all shown. But for, let's say, the picking in high wire crops, it's our experience, the first start for growers really to start robotization on a high level.
So maybe that's also a link to the topic around what hinders the most on adoption of robotics. Is it around skills of the growers? Do you see that as a big factor?
I didn't understand your question.
So, in order to adopt more robots in the field or within greenhouses or outside on the field, do you see challenges around the skills that growers or farmers need to adopt new technology?
Well, it's our experience that most of the farms are really eager to learn more about robotization, automatization, etc. So it's a relatively old conception, but it's beginning to develop robotization. So it has to be seen, and you have to convince growers by its efficiency. So how speedy it can work, and what is the accuracy of the work it does. Because if it takes more time to clean up the last remaining 20%, that would not convince, let's say, a grower easily. Okay. It's also the proposition that you offer to growers. Yeah.
So are there any other questions from the audience? Because we have had one. Come on, you have come here for a reason, to not only sit there and listen. Otherwise we have questions. Oh yeah. Guy over there.
Hi, thank you. My question is related with the cost. I know that the robotics can really help with the cutting cost. I'm from the UK. We're really facing a situation with growers. Mostly they have small and medium businesses. And I know robotics is doing a very good improvement. How long it will take to have robots available to be massive adopted, so growers can really get the benefits, but the small one, the one that cannot afford £100,000 or euros in a robotic solution, And because that at some point will dictate what will move forward. If we're looking for data-driven, we need to capture data for everyone in the industry. So my question is, when the robotic will be affordable with all the sensors, will be affordable for everyone?
Yeah, let's do a round, and maybe it also depends on the business model, because as a service for Christopher. So maybe do a round and then see what the different answers are.
Yeah, sure. I mean, definitely. And if you're a small, medium business, capital availability is probably not that great. So having suppliers that can provide robotics as a service is something that is highly valuable. That means that essentially it's just like a subscription you pay either on a monthly, quarterly, annually base. So that helps a lot with the capital availability and the liquidity needed for actually getting started with robotics. That can typically also unlock some other positives in terms of, having agreements in place that guarantee some availability of the robots, having agreements that actually work on a per output basis. There's a lot of models that are starting to become very prevalent in the warehousing space where it's a per pick pricing model. So every time you pick one fruit or every time you do one pick in the warehouse, you get X amount of cents on the dollar or to do that action. So some of those models are really starting to expand quite a lot in the warehousing space, and I would probably say that this is very highly likely to happen in the indoor farming space as well over the coming years. But this is something that, of course, puts the load of financing on the robotics companies or the distributors. So this is something that will happen over the course of a couple of years. But it's definitely a problem for small companies to invest in robotics if it's very high capex need.
What's your view?
Yeah, I mean,
Jochen?
I think nobody can really answer that question. If we could, of course, then we would maybe do other business or something and not research. But I follow this development now longer than 20 years, and you see it's getting major. It takes a long time, obviously. It is not something you can develop in a year. It will take decades, obviously. But you have shown the trend, so the rising labor costs and the aging society and so on. So there will come the point where it will get economic viable. I think technically a lot of things are already possible, but it's expensive. It is maybe slow. It is not 100% and all these kind of things. The discussion I heard or the comments I hear more from farmers and growers is also it's not so much about the price anymore. It's about they just don't have the people. So the alternative is to not produce. And that is more a societal question. So have the production has to move out of Western Europe into low-wage countries or something like this? I'm not so sure. But yes, to answer the question, how long will it take and how much will it cost, I think that's sort of impossible. It's a sort of very much depending on very many factors.
Thank you. And
okay, a small contribution to all those wise answers is for me it's a cash flow driven decision often or an investment driven decision. It depends the size and the states of your company. Meaning if it's cash flow driven, then you have the service as a solution option indeed, or you go looking for some more delicate, low investment robots. The example is it's a clear positioning or of Inaho to have a low-cost robotic, but obviously needs replacement much quicker than the durable investing project as a VDL leaf-cutting robotic, which is meant to last for ages, and indeed you can build out with a second arm in time to increase the capacity of the robotic. So it's a bit of cash flow driven or investment driven.
So, does it answer your question? Okay, great. So, we're almost out of time. So maybe we have room for one burning final question from the audience. Otherwise, we will end this session. So, we will see what the future will bring, and I do believe that timing is closer and closer getting to a lot of market readiness. So hopefully when we are here in the next years, we see a lot of market-ready robots active in greenhouses and on farms. And last week, maybe that's a nice thing to end the session with. I saw an article that ChatGPT had designed a robot in the tomato field. So maybe also that trend is developing that quickly that robots can be developed by ChatGPT like tools. So give a big hand of applause for the panelists, and thank you very much for your attention.